Here we are going to discuss ninth problem now. Ninth problem, he has given that to maintain a rotor at a uniform angular speed of 200 radians per second, omega is equal to 200 radians per second. An engine needs to transmit a torque of 180 Newton meter, 180 Newton meter in order to keep the uniform angular speed. What is the power required by the engine? Power required by the engine equal to, we know, power required in the case of linear motion equal to F into V, but in the case of rotational motion is nothing but force replacement is torque and linear velocity replacement is angular velocity. So torque is how much? 180 into angular velocity is 200. 180 into 2 is nothing but 360, 0, 0. Okay, this is nothing but watts, 36,000 watts. So power P equal to 36 kilowatts. This is the answer for this question. Okay, now next set of questions. Okay, now yes, 10th one is about a meter stick is balanced on a knife edge at its center. Initially the meter stick was balanced at its on a knife edge at its center like this. That means exactly at 50 centimeters mark. The meter stick is in equilibrium now. Okay, now when two coins each of mass 5 grams are put one on top of the another at 12 centimeters mark. This is 50 centimeters mark, this is 100 centimeters mark, and this is nothing but 0 centimeters mark. Two coins each of mass 5 grams are kept at a distance of 12 centimeter mark. That is one coin 5 grams, another coin 5 grams. They are put at 12 centimeters mark like this. The stick is, when two masses are kept like this, the center of mass will be shifted towards a heavier mass. So now the new center of mass, the stick is found to be balanced at 45 centimeters mark. Now the new center of mass will be this one. This is balanced at where? 45 centimeters. Okay, what is the distance between this 10 grams weight acting downwards? Okay, 10 grams weight is acting downwards. 10 grams mass into acceleration due to gravity is g. Okay, this is 45 centimeters. The distance between 12 centimeters mark and 45 centimeters is how much? 45 minus 12, that is 33 centimeters. That is distance from center of mass balancing point to 10 grams mass is nothing but 33 centimeters. And also the total mass of the meter stick is supposed to be concentrated exactly at the center of the meter stick. So mass of the meter stick is m into acceleration due to gravity g, m into g. What is the distance between 45 centimeters mark and 50 centimeters mark? This is nothing but 5 centimeters. How many forces are acting? One is acting here. This is one force. This is nothing but, this produces anti-clockwise torque, and another force is pointing downwards at this point, and this produces clockwise torque. So the system is at equilibrium at this point. If the system is in equilibrium, net torque is equal to 0. That means torque due to 10 grams. Torque due to 10 grams is nothing but R cross F. R is how much here? R is 33 centimeters. 33 centimeters into F is nothing but force. Gravitational force is how much? 10 grams into acceleration due to gravity. 10 grams into acceleration due to gravity. Okay, which is equivalent to torque of this mass of the meter stick. So distance is nothing but r is 5 centimeters into what is the force here? Mass of the meter stick is m and acceleration due to gravity is ga. This is the force. Okay, I equated this because net torque is equal to 0. This is anti-clockwise torque, positive torque, and this is nothing but negative torque. Clockwise torque is negative. This one is negative, which is equal to 0. Therefore 33 centimeters into 10 grams into acceleration due to gravity is equal to 5 centimeters into mass of the meter stick into acceleration due to gravity. So this acceleration due to gravity cancels each other. 5 1 ja, 5 2 ja 10. So now how much? This centimeter and centimeter get cancelled. Now remaining thing is only mass. Mass of the meter stick equal to 33 into 2 is nothing but 66 grams. This is the answer for 10th question. Okay, now I am going to discuss next problem. Yes. Yes, now 11th problem. Now 11th problem. What is 11th problem here? Yes, determine the kinetic energy of the circular disc rotating with a speed of angular speed of how much? 660 rpm rotations per minute. That angular speed equal to 60 rotations 2 pi radians per minute, 60 seconds. 1 rpm equal to 2 pi radians by 60 seconds, right? 60 seconds and 60 seconds get cancelled. Omega equal to 2 pi radians per second. It is in SI system of units. Now about an axis that is passing through a point on its circumference, rotating disc, circular disc, if the axis is passing through a point on its circumference and perpendicular to its plane. So now we know that moment of inertia of the circular disc if axis passing through center and perpendicular. Our aim is to find out the moment of inertia of the disc if axis is passing through circumference and perpendicular, so that these two axes are parallel to each other and the distance between them is r. Moment of inertia of the disc if axis passing through center of mass and perpendicular is how much? mr square by 2, and the distance between these two parallel axes is nothing but r. Therefore from parallel axis theorem, ip is equal to moment of inertia about the center of mass is mr square by 2 plus mass times square of the distance between two axes is nothing but mr square. That is ip is equal to 3 by 2 mr square. Now we ask you to find out what? See here, 3 by 2 with mass is equal to how much? 5 grams, 5 kg into r square. R is equal to 1 meter whole square. So here moment of inertia about the circumference and perpendicular to plane of the disc is equal to 3 by 2 into 5 is nothing but 15 by 2, that is 7.5 kg meter square. This is the moment of inertia about the circumference and perpendicular to its plane. Now we need to find out kinetic energy. So rotational kinetic energy is given by half I omega square. Of I is 7.5, omega is 2 pi whole square. By solving this you will get the answer in kg meter square. Okay, next one. Right, next one is 12th one. In 12th one he asked to find out what? See here, yes, two particles each of mass m and speed u travel in opposite directions along parallel lines separated by distance d. two particles are moving like this. One particle is moving in this way with mass how much? M, and speed is u. Another particle is moving in opposite directions. These two parallel lines separated by a distance of d. Another particle is moving like this in opposite direction with mass m and speed u. And these two parallel lines are separated by a distance of d. Separated by a distance of d. Show that the vector angular momentum is nothing but L equal to R cross P. R cross P is nothing but mv. Okay. Vector angular momentum of two particle system is the same whatever be the point about which the angular momentum is taken. So we need to show that angular momentum is same whatever the point of selection chosen. Right. I am going to find out angular momentum at point A, angular momentum at point B, angular momentum at some point C. Okay. Now angular momentum at point A is equal to angular momentum of this particle. This particle is passing through point A. That means it is passing through axis of rotation. So angular momentum is equal to 0. There is no perpendicular distance. So perpendicular distance 0 into mv. Okay. This is for first particle. And second particle. And second particle is moving like this about point A. So place for second particle perpendicular distance from point A to second particle. What is this perpendicular distance? D. So perpendicular distance D cross mass of this particle is m and speed is u. So m into u. Okay. So angular momentum about point A equal to 0 plus d cross mu. D cross mu. Similarly, I am going to find out angular momentum about point B. So now angular momentum about point B is nothing but this one. As this particle, second particle, consider this is first particle. Second particle is passing through point B. So there is no perpendicular distance for second particle. Perpendicular distance cross mass into velocity. Perpendicular distance is equal to 0 plus angular momentum of first particle about point B. Angular momentum of first particle is nothing but distance. Perpendicular distance d cross mass into velocity. Mass into velocity of first particle is nothing but m into u. Okay. So LB is equal to again d cross mu. Now I would like to find out the angular momentum about point C. Let this point C is at a distance of x from point A, so that this distance will be d minus x. Okay. Now angular momentum about point C is equal to, for first particle angular momentum, this first particle is at a distance of x from point C. So x into mass times velocity of first particle plus angular momentum of second particle. This is the second particle. Second particle is at a distance of d minus x from point C. So the distance is d minus x cross again mass times velocity is m into u. So here you will get x into mu plus d into mu, that is d into mu minus x cross mu. So here x cross mu get cancelled. So angular momentum about point C is given by d cross mu. So angular momentum is same whether we choose point A, point B, point C. See here point A, angular momentum at point B, angular momentum at point C are same. Therefore LA is equal to LB is equal to LC. It is proven. Okay, now I am going to discuss about next problem, that is problem number 4. 13. Sorry. I need to select total picture in order to drag down. Yes. Now I am going to discuss about 13th problem. The 13th problem is all about, sorry. Yes, the 13th problem is the moment of inertia of a flywheel making 300 revolutions per minute is how much? Moment of inertia I is equal to 0.3 kg meter square, and whose angular velocity omega, initial angular velocity is given by 300 revolutions per minute in SI system of units 300. One revolution is nothing but 2 pi radians divided by per minute is nothing but 60 seconds. Okay, 61 ja 60, 65 ja 300. So 5 into 2 is nothing but 10 pi radians per second. Omega 0 equal to 10 pi radians per second. This is angular velocity, initial angular velocity. Find the torque required to bring it to rest in 20 seconds. If final velocity is equal to 0 in next 20 seconds, if t is equal to 20 seconds, then what is the torque? We need to find out the torque. We know that torque tau is equal to I alpha. Here I is given, that is 0.3 kg meter square, and alpha is unknown. So before finding tau, we need to find out alpha. So we have known omega 0, omega and time. So from first equation of motion, omega equal to omega 0 plus alpha t, final omega is equal to 0, that is equal to omega 0. Omega 0 is nothing but 10 pi plus alpha into t. T is nothing but 20 seconds. Therefore, alpha is equal to, yes, minus 10 pi by 20 radians per second square. That means minus pi by 2 radians per second square. Minus pi by 2 radians per second square. We know alpha now. So torque tau equal to I alpha. I is given as 0.3 kg meter square into alpha is nothing but minus pi by 2. By solving this, you will get the answer in terms of Newton meters. Okay, this is the answer. Magnitude of torque is nothing but it will be positive. Okay, now the final one. Wait a second. Sorry. Once again, I need to select it again. Yes. Yes, a 14th one now. See here, the 14th one is when 100 joules of work is done on a flywheel, work done equal to 100 joules, its angular velocity is increased from 60 rotations per minute to 180 rotations per minute. Initial angular velocity omega 1 equal to 60 rpm, that is 60 into 2 pi radians by 60 seconds. Okay, and omega 2 is equal to 180 rpm, that is nothing but 180 into 1 rotation is nothing but 2 pi radians divided by minute. Per minute is nothing but 60 seconds. Okay, now what is the moment of inertia of the wheel? What is the moment of inertia of the wheel? I and the. So from work energy theorem, here we know omega work done. Sorry, this is work done. Omega 1 is known, omega 2 is known. From work energy theorem, net work done is equal to change in kinetic energy. Final kinetic energy minus initial kinetic energy of I omega 1 square. So work done equal to 100 joules, that is equal to half. I is common in both. Omega 2 square is known. and omega 1 square is also known. Omega 2 square minus omega 1 square. Both omega 2 and omega 1 is known. So substitute omega 2 and omega 1 values here so that you will get answer for I, moment of inertia, in kg meter square. So this is the last problem in this chapter. Have a nice day. Thank you. Bye bye.